There's a beautiful, perfect order to life on Earth that's so mysterious and so profound. Yet as people, we're so dysfunctional, and we seek guidance from the heavens to help us understand our purpose here and to create a sense of order.
The Interplanetary Podcast. The exploration of space for the benefit of all mankind. Your hosts here in London, Matthew Russell and Jamie Franklin.
Sufjan Stevens, one of the best musicians ever.
He's a really good songwriter. I'm not sure about musician.
No, he's a great musician. He plays everything.
He hardly plays it to Paganini standard, you know what I mean?
I disagree. I'm just challenging you on that, Matt, and I know that you, as a teacher, will welcome that challenge.
Yeah, no, that's fine.
I'm throwing it out there that he is a great musician. I've seen him live various times, 3 times, and he's played a myriad of weird and wonderful musicians very well and uniquely.
Yeah.
If anyone would like to challenge that, then bite my ass.
No, that's absolutely. It's music's subjective. It's not a competition.
It is. It's not. I tell you what, he is fantastic. Go and check him out. Me and Matt bonded very heavily on his album Illinois. If you don't know it, get to know it.
But he was writing about a track called Mercury, which was from his kind of planetarium piece that he wrote. And it's what a song. I tweeted it.
Beautiful, isn't it?
Yeah, it is absolutely beautiful.
So, thank you, Sufjan.
Going on the Interplanetary Podcast Spotify playlist.
Get in.
Jamie, do you know whose birthday it is today?
I don't. Hit me.
Stuart Allen Stu Rooser.
Ooh.
Now, do you know who that is?
I don't.
You don't? See, this is amazing. He's the module pilot for Apollo 14.
Ooh.
The command module pilot for Apollo 14. In other words, he's the ginger Mike Collins. That's how I like to think. That's how I like to think of him.
Yeah, I'm not sure he'd like to be called that, but there's worse things to be called, isn't there?
He tragically died quite young, actually, in his 60s. But yes, he took Alan Shepard and Edgar Mitchell to the moon. Of course, we both know those two. But yeah, he's one of the least famous Apollo astronauts, really.
He sounds like a legend.
Well, he is a legend. He's only one of 24 people ever to have left low Earth orbit for a start off.
Is that it?
And he orbited the moon 34 times.
Oh, that's crazy.
You'd think you'd know his name, wouldn't you? He's only 24. We're into space. But Rooser, not the most common name. Stuart Allen Rooser. It would have been his birthday today.
Well, happy birthday.
And Saturday marks a momentous day in Russian space, which was 1933 on August the 17th. The group of Soviet engineers called GERD, or the Group for Investigation of Reactive Motion.
I'm into it.
Yeah, successfully fired the first Soviet rocket that burnt liquid oxygen. So the GERD-09 experimental vehicle, or rocket projectile number 9. And it flew for 18 seconds and reached 400 meters in altitude before crashing to Earth.
Well, fair play.
Yeah, and that was under the leadership of Sergei Korolev, of course, but the team itself was led by a guy called Mikhail Klavdivich Tikhonravov.
You're doing very well, Matt.
Thank
and
you.
I'm glad it's not me saying it.
But it's really a hybrid rocket because the propellant was a jelly version of petrol, or gas, as our American listeners would prefer us to say, or solid benzene. It was like a jelly.
Need to stop and get some gas.
Even though it's liquid. Don't understand that. A book I want to find, Jamie, is Mikhail Tikhonravov's Reaching Asteroids, Ideas of Tsiolkovsky and Modern Age. In 1979 he wrote that book. And I wonder what the contents are like, but I just cannot find any reference to it, but I know he wrote it.
Well, there's some homework for our listeners right there.
Yeah.
Can you find, Matt, this book?
Yeah, I found the PDF of The World, the Flesh and the Devil.
That I ordered that book, Matt, on eBay.
Oh, nice.
There was just one second-hand copy and I snapped it up.
Oh, yes.
Can't wait to read it.
I'm actually really jealous now. That is very cool, Jamie.
I was well happy.
We didn't have any space news last week because we had an absolutely jam-packed episode with interviews and stuff. I think that may have been
it was
longest
like
episode.
Our notes for that was like War and Peace. I tell you what. But so we've got some extra stuff to go over this week. Lucky you.
Yeah, luckily we had to keep some of it back. So did you see last night, we're recording this on Wednesday, by the way, so last night, Luca Parmigiano and his DJ set from space. Yeah.
Well, I mean, it did twist my melon a little bit. But you rightly said on Twitter, who's the guy standing next to him? I'm assuming he's not on the ISS.
Yeah, I know.
That was something on the ground.
Exactly. Yeah, that publicity shot of Luca with some other DJ messing around on like Pioneer CDJs and DJMs. That obviously is that's probably
definitely
an S-Tech, isn't it?
Definitely don't look like they're in 0G as well.
No. It's that's definitely a mock-up. Because they can't have flown a DJ up quickly without us knowing.
And plus, Matt, we all know that Pioneer hasn't got the quality that Roland has. If you want a DJ controller to work in space, you're going to need the brand new DJ 707M released today.
Oh, wow. And that's interesting. All I know about the Pioneer stuff is the gain structure on it is quite literally a joke. And it really, as like a pro engineer, they really annoy me. They really annoy me. But I mean, that's what everyone uses. And to be fair, the CDJ can play anything, man. You stick in your iPhone and it will play the MP3s off it. So it is pretty useful.
Yeah, but
I don't know. No. Yeah, I don't know what's going to happen.
But I can't believe it, Matt. I mean, a DJ set in space. I hope he took our playlist up with him.
Well, I'm assuming he just played our playlist, which is, of course,
what else do you need?
The joke of DJs. I mean, are we saying that the records he had on the ISS weren't available to the DJs on the ground? Don't get me started. Don't get me started with DJs, Jamie.
Don't get me started.
I'm an old man that just doesn't get it.
He's a very grumpy old man. Leave him alone. Don't poke the bear.
So, in news, Tim Peake was also at that festival. It was all part of the Stockholm Culture Festival, which is going on. And their theme this year is space. And Tim Peake and Thomas Reiter are both going to be there making personal appearances. But Tim Peake is taking an unpaid leave of absence from ESA for 2 years.
Why? Where's he off to?
He's off to sort of concentrate on the UK Space Agency and their education and outreach. And of course, He's got his job with the Prince's Trust. He's a Scout ambassador. But what's interesting is ESA director said that all of the astronauts in the class of 2009 will fly twice by 2024. So Tim Peake will definitely return back to ESA in a couple of years' time to continue his training and finish off his tour of duty, as it were.
Maybe he's taking a break because he's scared that we're going to interview him again because you used the peak joke in your first sentence. Yeah,
we peaked early. That's because we were interviewing him in January. Jamie, let's move on from my terrible moment. Well, the worst bit was I forgot to press record on the microphone. That was even
definitely
better.
Not the best moment.
I tell you what, though, Jamie, did you see the close shave of Asteroid 2019?
I didn't. What happened?
There's an asteroid called 2019 OK, 100-meter wide asteroid, and it was only detected days before it passed Earth, and was really, really close, i.e. 65,000 kilometres away. That's half the distance. Well, much less than half the distance to the moon. So it's come in between us and the moon. Now, had that hit us, that would have been a once in a 10,000-year event, and potentially as powerful as the 50 megaton Zara bomber, which would not be good. And you know, there's estimated to be about 30,000 of that size asteroid out there that have yet to be found. We've only found a couple of thousand of them, and we know by the maths and statistics, there's another 30,000 of them floating out there. So
that's why we should make hay while the sun shines.
Yeah, absolutely. Or maybe take planetary defence slightly more seriously than we do.
Yes, please.
Now, did you see that Franklin is in trouble?
Of course he is.
The Rosalind Franklin rover.
Oh, you mean Ros?
Yeah,
oh, right.
old Ros. Yeah, that.
I thought you were talking about one of my cousins or something.
Oh, no. Well, I was talking about you. You're in trouble, but we'll talk about that off air. No, it's there might be a delay. It might not go up in 2020. Unlike the NASA Russell rover, and I'm assuming they're going to call it the Russell rover after
of course they will.
Esteemed astronomer Henry Norris Russell. How cool would that be if both rovers are the Franklin and the Russell?
That'd be perfect.
It would be epic. So but anyway, the NASA one's fine, but the ESA one, there's a problem with the parachute. Now, as far as I can tell, the Franklin rover parachute is the biggest ever space parachute by far, because Curiosity's parachute was only 16 meters across. This one that failed, had a bit of problems, is 35 meters across.
That's big.
Yeah, and it's got 3 miles of cords all wrapped up in as well, and takes 5 days to fold up and configure.
Whoa.
But I did find a bigger parachute. So when NASA was developing the Ares 1 booster, ATK tested a 1-ton, 45-meter parachute. That must be the biggest parachute ever. If not,
well, surely
it's another thing for our listeners to maybe find out if there's a bigger parachute than the ATK 1-ton, 45-meter parachute for returning the Ares 1 booster.
I dare you. I double dare you.
I triple dare them.
Physical challenge. Do you remember that, Matt, at school? Physical challenge.
Oh well, yeah. I never used to like it unless it involved. If it involved like distance running, I'm terrible. I've got something wrong with me. But like physical strength, Jamie, as you know, I'm a machine. Essentially,
you are a machine.
They call me the Arnold Schwarzenegger of Devon now.
Well, people are very much looking forward to our 100-meter race.
Oh yeah, I forgot about our 100-meter race
that we're going to have to film.
Oh yes, definitely.
We will live stream that. Stay tuned.
Oh yeah, I forgot about that. Well, we're definitely
in a world of trouble.
Oh my god, I can't wait. It's all changed with small sats, Jamie. A few weeks ago, SpaceX and Soyuz both entered the market by saying that they're going to do regular rideshare missions. So just have each month or so.
Well, about time, I say.
Yeah, and so they were just going to go up with lots of satellites, and you knew exactly when the next rideshare was, so you could hop on and get into space if you're a nice small satellite.
I love it.
Which, in conflicting kind of circumstances, Vector Space are having a good week by having the US Air Force awarded a $3.4 million contract to launch Aslon 45. But then 2 days later, the CEO Cantrell left and the company started laying off everyone, leaving John Garvey in charge. So it's not looking good for Vector Space. And in the meantime, Rocket Lab, did you see Peter Beck announcing that Rocket Lab are going to go reusable? We're going to catch it with a helicopter as it parachutes down. And I wonder if that's how Orbix were going to do it. You know, he was being very mysterious about how they were going to make it reusable. I wonder if that's how Orbix were going to do their reusability as well.
You could be right. Well, that is good news.
Yeah.
We're all for that.
Yeah, all for a bit of reusability, less environmental damage, perhaps. Who knows?
Less is more.
Yeah, and Orbix have signed a deal with ISL, a Dutch company, and with a UK company called InSpace. They've been signing deals to launch satellites. One of them, the InSpace, the UK one, is the Faraday 2B satellite that might launch from Scotland in 2022.
Ooh.
So that's probably...
That's not far away.
That's not far away at all. 3 years, Jamie.
I can't wait. I can't wait for UK launches. Come on, hurry up.
And in more small sat news, I suppose we've got the Chinese startup Link Space that have been testing their rocket hop test.
Ah, yes.
So now we have SpaceX, Blue Origin, the Long March 8, Rocket Labs, and now Link Space, all capable of reusable booster technology, or on their way, leaving Europe trailing quite a bit behind, I think.
Yeah, we need to catch up. It's the future.
Did you see that the little moss piglets potentially survived their trip to the moon on the Beersheet lander?
I did see that. That is excellent stuff, and I'm happy for them.
Of course, they're all dried up and desiccated.
Well, aren't we all?
They're encased in a epoxy amber as well. But you could go and revive them, but they're definitely not going to suddenly sort of like crawl out and start infesting the moon.
Sorry to any amber that was offended by that.
Not poxy amber, epoxy amber. Jamie, you knew that. A few hours ago, Jamie, one of the most exciting things are going from Israeli moon attempts to the Indian moon shot.
Really?
And the Chandrayaan 2. Chandrayaan 2 that's been orbiting the Earth recently, sort of making its orbit bigger and bigger and bigger. It got to an altitude of almost 143,000 kilometers at its apogee. A really elliptical orbit because it's only 276 kilometers at the nearest point at perigee. But it has done a successful translunar burn and is now on its way to be caught by the moon by about August the 20th to be landing on the moon on September the 7th.
That is beautiful. I can't wait for that.
It's going to be absolutely cool. The X-37B that we've talked about, that's now gone way past 700 days of being in space, doing what only Dodd knows. That's a joke about God rhyming with the Department of Defense. Dodd.
Good man.
Thanks. And it's I reckon it's testing Trump's American liquid metal nuclear propulsion.
Oh yeah.
There was Trump was bragging that they had the same technology as the Russians when the Russians one blew up, and everyone was going, "Oh my God, they're developing this liquid nuclear propulsion for their missiles," which is pretty bad news.
That is
mini Chernobyls. They're called.
Could you imagine?
But a really interesting paper, Jamie. You'll love this. So, an interesting paper by a guy called Jakob Lustig-Jaeger, Victoria S. Meadow, and Andrew P. Linkowski.
Oh, yes, I love that.
All of those have got great names, haven't they? They came up with a paper that was published in the Astronomical Journal that basically points out, and they do lots of simulations to prove that the James Webb Telescope might be able to do some really good atmosphere detection of the TRAPPIST-1 system during its first year of operation. So as soon as JWST is up and running, we might have some of the most incredible news from TRAPPIST-1 within a year.
That is going to be... I mean, it's just so much going on, isn't there?
Yeah, there's a lot going. Well, that's not going on yet, and of course, it could just blow up on the launch pad with.
Matt, where's your PMA?
Well, has to be said, Ariane 5 did its third launch of the year just now, and it was the heaviest payload it had ever done. It's improved its performance. It's something like the 145th consecutive nominal burn of the upper stage engine so Ariane 5 is really, really, really reliable. So it's looking good. It's looking good. That's if Ariane 5 is still flying by the time JWST is ready.
Is that true?
That it might not be flying?
Yeah.
Well, yeah. In Ariane 6 will be taking over at some point. And if the James Webb Space Telescope isn't ready by that turnover, you can't just sort of keep... Ariane 5's lying about. They have to sort of be made, and the production run may have ended by then.
Matt,
it's unlikely.
Every time you say James Webb, I just get nervous.
I know. It is. It is nerve-wracking because that is many, many billions that rely on a really, really complicated launch. Yeah.
It is scary, but, it's going to work, and we'll be there, won't we, Matt?
I follow a guy, luckily, called Chuan Do,
Does he know?
I stay quite a long way behind him, but it's and plus, my training.
Yeah, true.
You can't really see me.
Stealth.
But I follow him on Twitter as well, and he came up with a very interesting little tweet that was an infrared image of the supermassive black hole Sagittarius A star at the center of our own galaxy.
Yes.
And it flared brighter than it has ever done, at least twice as bright as it's ever done in the 20 years of observation. So something is making it flare up, and they don't know what it was. So that it could be really big news. So it's definitely worth staying tuned to that story. He's written a preliminary paper, so there's a link to that on his tweet, which I've included in the notes. But yeah, remember a couple of years ago there was a massive sort of dust cloud, or a gas cloud, I should say, that came really, really close to the black hole, and they were able to sort of watch how it went past and everything. They think that it might be something to do with that, or it might be that the star SO2 that gets really close to the black hole made some changes to the accretion flow in the accretion disk, but they don't know.
You know I love an accretion flow.
Black hole flare-up, so that's pretty exciting. Yeah, Tuan Do of UCLA.
Black hole flare-up.
So yeah, let's get on to space habitat stuff, Jamie.
We're
supposed to be in space. We're supposed to be in Space Habitat Month, so we ought to maybe talk about it. So,
well, we probably should.
The really big problem with all these massive space habitats that we've been talking about, your Bernal spheres and your O'Neill cylinders, is you clearly can't launch them from Earth. There's just too much mass. And ideally, you want to build these things from the resources in space.
I'm agreeing with you, yeah.
Which means we have to start manufacturing in space.
Yes. Definitely.
And I'm going to give you a little bit of history about manufacturing in space, because this is actually quite exciting. So have you ever heard of a thing called Z-Plan or Z-Plan?
I haven't.
Weirdly, if you've read the book Artemis by the same author as The Martian recently, he has a material called Zafo, I think it's called, and it's very similar to Z-Plan. Z-Plan basically is a heavy metal fluoride glass that was accidentally discovered in 1975 by Poulain and Lucas of the University of Rennes in France. And it's called Z-Plan or Z-Plan because it contains zirconium, barium, lanthanum, aluminium, and sodium. Of course, the chemical symbol for sodium is Na, hence the N, Z-Plan. And yeah, so that, but this stuff makes the very best fiber optic cable. As in, it's so much better than normal fiber optic cable.
Okay.
But not only that, if you make it in 0G, it becomes even better because of the way that the crystals form. It doesn't block the light, so you get this absolutely brilliant fiber optic cable.
Wow.
The company Made in Space actually have like a microwave-sized device on the International Space Station, a kind of 3D printing device that pulls Z-Plan and makes it on the ISS, then brings it back down to Earth as a commercial product.
That is genius.
So, in some ways, Made in Space might be the first truly industrial process that in space. And also Made in Space have got their microwave-sized 3D printer that they've been printing objects in space as well. So that's the first commercially available 3D printer in space. So Made in Space really do know what they're doing when it comes to manufacturing in space. In fact, might go down in history as being the people that very much started it.
Sounds like it.
And let me quote Jason Dunn, who's the co-founder and CTO of Made in Space. He says,
yes.
For Made in Space, projects like RAMA that exist somewhere near the edge of our product roadmap help drive all our closer teamwork in the right direction. For all of us in the US, we are lucky to have an agency like NASA, which has the vision to continue to fund NIAC and other programs that will define the future resiliency of our species. think, yeah.
Hell of a quote.
Yeah, the NIAC, the Innovative Advanced Concepts branch of NASA. And they paid Made in Space a lot of money to come up with this RAMA.
Do you know what that stands for, Matt?
Oh, go for
it. Reconstituting asteroids into mechanical automata. What do you think about that?
It's really intriguing for a start off, isn't it? Because there are quite a few concepts in this paper that took me a while to get my head round. So, yeah, the objective of the study is to establish the feasibility of using the age-old technique of analog computers and mechanisms to convert entire asteroids into enormous autonomous mechanical spacecraft.
This is it. It's a simple theory.
It's a simple theory to go out, get the asteroids and turn them into essentially mechanical spacecraft to retrieve them into a place where we can actually go and get them. Mining asteroids at the moment is just way more expensive than mining the same materials on Earth, which is why, this asteroid mining just isn't quite feasible yet.
Yeah, so, but you've got to speculate to accumulate, Matt. They need to get up there, get the cash.
No, absolutely. And one of the resources actually that's been developed in this paper, which is this asteroid finding software, might very well be a very useful bit of software for anyone who wants to speculate to accumulate on asteroid mining.
Here we go.
But we'll get onto that in a minute. So, Made in Space made the report to try and address these issues. So the main issue with building space-based infrastructure. So that's things like if you want to build a space station, you kind of need this technology in place. You just cannot lift all this stuff up. The need for space-based resources. How do you get all these resources that are just lying around in space? To overcome some of the launch and propulsion problems.
Yeah, data collection, Matt, and asteroid detection.
That's a huge one.
It?
It's bigger. Yeah, it's bigger than you think actually, because as we'll see, like detecting what an asteroid is really difficult. Well, as we just heard about we don't even know where all the asteroids are. We just know that they're there somewhere. How to remotely mine asteroids without the need of humans, so how to do that with robots, etc., and how to get miniaturization of all these things so they get better and better.
What about generative design algorithms?
Yeah, that's pretty important as well. But the main core problem that they think is the transportation of asteroid resources, and that's what RAMA architecture is all about. It's how you go and grab one of these massive asteroids and get it into a place where you can actually usefully mine it and start getting the stuff off it. So all of space industry at the moment is just about data. That's it. There's no physical products apart from the odd bit of fiber optics, which is made in space. So literally it's just about data. So the project in a nutshell is, what would it take to turn an asteroid into a self-powered spacecraft?
The big question.
The concept is based on a seed craft. So you've got this spacecraft that contains a sophisticated ISRU. Do you know what that is, Jamie?
Oh, no.
In situ resource utilization.
It was on the tip of my tongue.
It's going to be the buzzword of a lot of things from now on in space. It's all about how do you use the stuff. Like when we go to the moon, the only way we can really make a moon village work is through ISRU, in situ resource utilization, or going to Mars and making methane using ISRU. So then you've got additive manufacturing and robotic capabilities all on board this seed spacecraft.
Wow.
And then that arrives at the asteroid and it converts the materials of the asteroid into the spacecraft subsystems. So the materials of the asteroid get made into propulsion, energy storage, guidance systems. So, and at that point, the asteroid becomes a spacecraft in its own right and can autonomously carry out a basic mission, i.e. fly itself back to a place where it's easy to be collected. And then in the meantime, the Seed spacecraft has undocked itself from the asteroid and gone on to attach itself to another
it's just
asteroid and begin the process
amazing.
all over again.
God damn. It's incredible to imagine, isn't it? I mean, it's hard to imagine, but if we think about in the future, if this becomes the case, which undoubtedly it will, I mean, that is mind-blowing, isn't it?
So many neat ideas. The really big idea, really, in the sort of first part of this is that RAMA's using the materials that it finds at the asteroid for the mass, all these things that are mass intensive. So instead of taking up things like tons of propellant,
just build them there.
Yeah, you try and work out a way of building the propulsion system using the mass of the asteroid itself.
Yeah, right.
Of course, that means that more mass can be returned to low Earth orbit where it can be actually used. And the most incredible, like one of the sort of bigger concepts as well, is if you could have a train of mechanically driven asteroid spacecraft or mine carts that are stretching to the depths of the asteroid belt and bringing stuff to Earth, so they could remain in a kind of orbit, and you just fill up these hollow asteroids with stuff, and they just keep delivering new materials all the time. So you can actually set up a kind of train system. Yeah,
how amazing is
that? Which is really exciting.
It really is. I mean, because if they can work out what the asteroid is made of, and they need that metal or whatever it might be to build a machine that's going to mine the asteroid or whatever. I mean, that's the way forward, isn't it?
Yeah, and ultimately it gives humanity access to that area of space, safer, faster, and cheaper. So it's a really, really interesting, paper. But one of the things is finding the asteroids in the first place. And through observation, you can only, through telescopes, you can only really sort of tell a few things about an asteroid. You can only really tell its apparent position. Then you kind of work out its apparent magnitude. Yes. And then from its albedo, you can work out its absolute magnitude. And then from that, you can just about work out its diameter. But that's a lot of work to get even to that. It is. And what you really need to do is find its diameter, its composition, its detailed composition, its rotation period, its shape, its mass, density, and porosity. And all of those are incredibly difficult to find out. In fact, you can only really find out an asteroid's mass density and how porous it is by actually visiting the asteroid itself. So that's huge. So it's one of the things that the Seed craft has to be able to do is analyze.
Yeah, just go and get all the data, exactly like you said. How important is that?
So you've got your common types of asteroid. The worst kind of mentioning, you've got your dark albedo, low albedo, carbonaceous asteroids, which are the C type. And that makes up most of the asteroids in the outer belt. They're less common in near-Earth orbit. They've got low density and high prevalence of organic compounds like water, ice, and other volatiles. Then you've got your silicaceous asteroids, your bright S asteroids. They're bright and they're in the inner belt, so they're closer to Mars, and they're also the most common near-Earth object type of asteroid. And they're normally stony and metallic in composition, but they have very little water, ice, or volatiles. And then you've got your metallic asteroids. And we've talked about an asteroid called Psyche 16 before when NASA announced the Psyche mission. And that is such an interesting object, a big solid metal asteroid that could be the core of a Mars-sized planet.
Is this the one that you thought was made of gold?
It's almost certainly made of gold. And if you divvied out all the gold to everyone on Earth, we'd all be billionaires if the gold market hadn't crashed hideously.
Cheers, gold market.
So Psyche 16 contains an insane amount of heavy metals and rare metals. And yes, I mean, as a kind of gold mine, there is no place in the solar system better, probably.
That is...
So you've got your three different types of asteroid, which would change how RAMA itself would operate at each one. Do you remember the Antikythera device?
Yeah, barely. I remember it a bit, yeah.
There was a program about the Antikythera. The BBC did Horizon, and if you've never seen that, you have to watch it because it's one of the most amazing programs I've ever seen. Basically, they think Archimedes built what essentially is a computer, and no one built anything as sophisticated for another 1,000 years. It's 2,000 years ago, and they found this thing by luck, and they sort of were able to kind of see through this rusted copper disaster and work out all these different cogs and how it basically represented the solar system, even the way that the moon orbited the Earth in its elliptical orbit. They were able to represent that by these really clever ways of altering the cogs. It's absolutely an amazing device, like just mind-blowingly good. But the reason why I'm talking about it is because the idea that Made in Space have is to change the asteroids into that kind of device, an automata, a mechanical computer. So instead of bringing up like complicated electronics that are hard to make in space, you can build all these mechanical things in situ. So mechanical computation devices like the Antikythera.
Wow.
And if Archimedes can do it 2,000 years ago, why not get a seed spacecraft with modern technology to be able to build it now? So you could build even the guidance systems, the guidance, navigation and control systems from these really clever mechanical computers. And maybe that would be a way of saving mass. Instead of taking a computer, you just have a small instruction set
build there.
It means that you can build there. Yeah.
Jeez.
The flywheels themselves that would sort of steady the asteroid, that they would be built in situ, and of course the propulsion system. I think the propulsion system is the thing that is most likely to be sort of made in situ.
Yes.
I think actually the command and communications and guidance, navigation and control systems, I think is a little bit far-fetched to be made mechanically, and especially considering how light a computer chip is these days. It seems
pretty light.
Really, you couldn't just take like 100 of those up in the seed spacecraft and speed up the process of making these things. That's the only thing that I'm a little confused about. But of course, that's the whole thing. So it's up to the designer of the RAMA for that particular asteroid. What is the bring versus build trade-off for any given asteroid?
That's a good question.
And with propulsion, it's really, really obvious. So if you were to bring the propulsion from Earth, it would double the mass of the seed craft, even for a 5-meter asteroid. But we want to bring 100-meter and bigger asteroids back because there's no point just grabbing a 5-meter asteroid. That's pathetic. So, which would be impossible. You just wouldn't be able to take up enough propulsion to be able to do that. So the propulsion system seems really, and I can't wait to tell you about the propulsion system because that is so crazy cool. Let me give you an example. I'll give you an example of the RAMA process from beginning to end. So you've got RAMA 1, which is in 2038. So 19 years' time. Should be very exciting. So the RAMA seed craft will use electric propulsion and gravity assists to get to the near-Earth asteroid 2009 UY19, which is 36 to 163 meters wide, and will be within 15 lunar distances of Earth in 2039, and approximately every 33 years thereafter. So it gets pretty close. So it's able to visit it fairly easily. And when it arrives, it starts organizing the available in situ resources by analyzing the asteroid. Then it starts breaking down the asteroids and all the materials using lasers and robots and all those kind of things, and starts stockpiling all the feedstock, and all the waste is going to be used as mass for the propellant. And all these techniques are being pioneered by NASA, epic. KSC, SwampWorks team, and all those industry mining initiatives that have been happening. And And then a mechanical energy storage systems are fabricated on the asteroid and charged with power from the seed craft. So the seed craft's got big solar panels that will be able to store some of this energy in things like springs and, well, we'll get onto these wobbling massive steel structures in a minute. And then the seed craft assembles a unique array of mechanical linkages from the asteroid, using in situ resources, derived components, and that will allow the timing control of the asteroid's systems. And then the seedcraft departs, triggers the asteroid's pre-programmed sequence of events, and then makes its way on its own to the Earth-Moon Lagrange 5 point.
Ah, yes. L5.
And that's where the asteroid mining activity is already underway, and RAMA 1 resources will be incredibly useful. And the Seacraft has gone on to start building RAMA 2.
Wow, that is so special, isn't it?
So one of the cool things is this analysing asteroids, and there's a piece of software that the RAMA team developed called Rock Finder, and they're going to eventually release this piece of software, and they say that it potentially has a disruptive kind of thing that if you're into future asteroid mining, it's essentially, if you've got this piece of software, you can suddenly realize, oh my God, it's actually worth going to this asteroid and mining it because it's going to be so valuable. So this piece of software could be something that, if you're taking asteroid mining seriously, something that you need to get your hands on, basically. So Rock Finder is...
Rock Finder, there we go. You heard it here first.
Rock Finder. So let me just tell you about the way that this asteroid is going to swim through space like a giant jellyfish.
Now, this is what I've been waiting for.
I've been talking about this with George, and we're trying to work out, like, is this the best method? But it's so cool and so novel that I've never heard anything like it. So I thought I'd just want to speak about it. But they worked out that there's different types of propulsion for different types of asteroid. We talked about the C, the S, and the M type asteroids. If it was a C, you might want to use just the volatiles that are there to actually create just your normal kind of liquid oxygen and liquid hydrogen propulsion, just like a normal conventional rocket.
Yeah.
But if you've found a S-type asteroid, this mechanical mass driver might be very much the way forward. So the mechanical mass driver, what the hell is it?
Whoa.
So what basically the SEED spacecraft, it starts mining the asteroid and it creates lots of waste mass, but at the same time starts to make steel, right? And this steel made into very, very long, thin beams of steel that extrude out of the asteroid itself. So you can imagine that the asteroid has these enormous steel bars all sticking out, all in a big massive circle all around the asteroid.
Yeah.
Right? Now, the SEED craft, once it's finished construction of the asteroid, it's using its own propulsion system, starts to kick the asteroid. So it goes, just gives it big forward nudges, right? Now, those kicks don't really impart any kind of significant delta V, but if they're properly timed at the fundamental frequency of these 16 extended steel rods that are protruding from the asteroid, they start to swing back and forth. Can you imagine, like, you keep knocking it and these massive steel bars start like swaying around. Now, so these slings begin to oscillate back and forth. And after 3 days of continuous kicks, the slings are rocking back and forth with high enough amplitude to bend all the way down to the asteroid's surface. And the slenderness ratio of the slings, 250 to 1, is large enough to remain fully elastic when bent that far, allowing it to oscillate like a pendulum with only a bit of thermal loss of energy, right? So the SEED craft then disengages and flies off to its RAMA 2 target.
Right.
And once the slings are in motion, they oscillate at a period of 2.1 seconds. And at the peak of their swing, the tips are traveling 312 meters a second, which is the theoretical maximum velocity of the material. And at the extreme of the swing, the tip picks up a bit of the asteroid material that's been mined using magnets that are on the end. And as it picks up this 10 kilogram piece of waste material, it flings back up. And as it gets to the kind of maximum arc of its swing, it throws that 10 kilogram shot into space. And of course, that means that it's throwing a mass behind it, and therefore the reactive force is pushing the asteroid forward. So you've
Couldn't
got
that potentially be dangerous, Matt?
Well, I mean, it's just chucking rocks in space. I mean, it's as dangerous.
But those rocks, could it hit the next asteroid behind it, breaking some of the machinery?
I don't know. I doubt it.
I'm very concerned. I need to speak to these RAMA lot.
Well, it's something that's worth bringing up.
Do you think they've thought of it?
I don't know, but I think everyone just assumes the sparseness and the vast emptiness of space. I mean, that's the thing. It's so
Matt,
empty.
What have I told you about assuming?
Yeah, no, it does make an ass out of you and me. So we should. It's worth bringing up that point. I wonder if it is a point.
Well, we should get one of them on the poddy.
So, at full throttle, with all slings operating, the asteroid accelerates at 11 micro Gs, which is pretty good.
That's pretty good, isn't it? That's all right. That's all you need.
It will look like a jellyfish, basically. These massive steel slings swinging back and forth, picking up rocks and firing it out. I'd love to see a brilliant animation of that.
That would be so good. Do we know anyone that could make an animation? Listeners, how good are you on animation? Please, someone make this.
Well, I wonder. George might make it in Kerbal.
Let's try it. Let's stick it up.
You need quite a few mods in there. So, there's other uses, of course. You could actually use this for asteroid deflection. You know, if there's a near-Earth asteroid heading to Earth, you might be able to stick these steel structures on there and actually deflect it enough so that it doesn't hit Earth.
Change its course. Wow.
Just because you've got this hollowed out asteroid arriving at Lagrange point 5, you might want to hollow it out more and actually have a pretty decent spacecraft. You know, a whole new type of spacecraft, or even a space habitat. You know, this could be perfect for a Mars transportation system. So an asteroid that's been hollowed out, you kit it out with all the necessary stuff that you want, including nice environment. You can even spin it up a little bit to create a small bit of gravity, and off you go. You've got a really nice spacecraft for going to Mars in, for example. So,
well, I love it. I'm into it. Sign me up.
It's just so cool, isn't it?
Isn't it cool? This is one of the coolest. This is why we've dragged it over a few episodes. Got to get some pictures up. It's so good.
I've put a lot of pictures in the notes. I just think there's so many really cool concepts. The concept of turning an asteroid into a spacecraft is cool. It's not new. Goes back quite. We talked about it last week. That goes back. But this idea of that type of mechanical jellyfish style propulsion system, the idea of making some of the subsystems, your guidance and navigation, like the Antikythera mechanism, is just like, that's so cool, isn't it? I mean,
beautiful, isn't it?
Yeah, it's really, really cool idea. And Made in Space are a really cool company. They're a really cool company. So I'm going to look at what they're doing over the next few years and go, wow.
We need to keep a close eye on them. I think we should invite them in too.
Yeah. Oh, we should definitely try and get someone from Made in Space.
We're going to reach out.
Very, very, very cool. I thought, just to finish up, Jamie, we would just talk about some of the other NASA concepts that are like the ones that we've been talking about, where this RAMA initiative. By the way, I noticed in the report, RAMA, that it didn't mention Arthur C. Clarke at all. It didn't mention the RAMA thing.
Seems
and I was thinking,
unfair.
Well, I thought that was really, really odd. I was thinking maybe they were just unaware of it. But luckily, I did find a blog post. I did find a Medium post by Jason Dunn where he does actually say that the inspiration behind it was actually Arthur C. Clarke's RAMA. So it was odd that wasn't mentioned in the report, but yes, it does actually come from Arthur C. Clarke's RAMA.
Well, I think they should name him.
what have we discussed over the last few weeks? We've discussed Bernal spheres. We've discussed Stanford toruses. We've discussed O'Neill cylinders, but there's a few others that are sort of similar variations on those, Jamie, that I thought we may as well just quickly rattle through.
Let's do it.
Have you ever heard of the Lewis 1?
Can't say I have.
It's just another cylinder, but it's a lot smaller than the O'Neill cylinder.
Tick.
The Kalpana 1, which is another short cylinder, which is I think is just an updated version of the Lewis 1. But one of the ones that comes up quite a lot is the Bowler, which is essentially if you've got a spacecraft on the end of basically a long piece of rope.
Yes.
You can spin those, and as long as you've got the counterweight on the other side, it would give you this, artificial gravity. The only problem is if there's any change in weight on either one, it would spin out of control, which is pretty worrying. So you need quite a bit of control and way of actually exchanging weight between the two systems. So they've actually thought about things like if you've got a habitat on each end, you could use the plumbing and things like that to kind of keep making sure that the counterweight was exactly right all the time. But that is actually probably the cheapest way of making artificial gravity, because really the gravity equipment is just a cable. That's it. Yeah. That is your gravity equipment. But the thing is, as soon as you start sticking radiation shielding and stuff like that on, then you need a very strong cable, and then the cable starts to get really, really heavy, etc., etc. So, how do you build up a giant habitat? And one of the things that NASA thought about, instead of using resources from space, is to use these things called beaded habitats, where you start maybe with the Bowler, where you've got where you've got two small, say like the International Space Station, each one of those modules, you've got one of them on the end, and then you start connecting more and more habitats, each of these little tiny beads, as it were. First of all, it would be a dumbbell, then it would turn into a bow tie arrangement, then a ring, and then a cylinder of beads. And then you could have an array of cylinders and things like that. So you could build up giant space structures using these kind of tinier components.
Wow.
But yeah, so it's a way of sort of growing a space station, which I think is quite an interesting one. Although you're then stuck with these small habitats, which isn't great. You haven't got these to be
stuck.
Exactly.
With one of those.
You haven't got these open vistas of, say, the O'Neill cylinder or the Stanford torus. So that's what makes those so appealing, isn't it?
So appealing.
Then we talked about Dandridge M. Cole and his hollowing out of asteroids.
We did.
So, and of course, Project RAMA is a hollowing out of an asteroid and using materials to get it to go where you want it to go. Well, there's a thing called the bubble world that Dandridge came up with, and basically you drill a massive hole in the asteroid, right?
Yeah.
And then you fill it with water, and then you heat up the outside of the asteroid until it starts melting. And as you spin it very, very fast, the whole thing starts to expand like a big ball. Imagine like a glass blower. It's like that. Yeah. It's like a glass blower, but on a massive asteroid. So you're sort of creating a bubble of material. And so you can make whatever form you want. And then once it's set, you go in and you kit it out as a habitation. So yeah, I'd
like to have a go. Have you ever done glass blowing, Matt?
No, I haven't actually. Have you?
Yeah, no. It's probably not the kind of thing you can just do at your local leisure centre, is it?
Well, it might be. It's the sort of thing you can do down your local community college, maybe. I don't know.
Well, I'm going to look into it.
Kim Stanley Robinson, one of my new favourites, wrote about terrarium asteroids, so asteroids that you've hollowed out. And again, he puts a lot of detail. Kim Stanley Robinson obviously got massively into this idea of hollowing out asteroids and spinning them and building, like, you could do whatever you want with them is exactly the point. You could turn them into spacecraft, you could turn them into habitats, you could turn them into trains, a bit like that RAMA thing, where you essentially have these things just staying in the orbit they were in, but that way you can use these things as means of getting around the solar system.
That's right.
As kind of just, you get on one, get on the next, and they're nice and comfortable inside because you've spun them up to give you artificial gravity, and there's nice fields, and you could have whatever kind of vista that you wanted inside. What
would you have, Matt?
I would have the town of Ilfracombe set inside the asteroid, so you wouldn't know you'd left. And
beautiful. There you go.
As Kim Stanley
Robbins,
Robbins,
think that you're very happy, Matt, and you're content in life and where you are.
Yeah. Kim Stanley Robinson describes it as walking into a map that's been rolled into a tube.
Oh, I like that.
Believe. Yeah. The last two are your mega behemoth gargantuan designs.
Here we go.
The bishop ring. Now this is you like a bishop ring, don't you?
Oh, you said it, not me. For once, it wasn't me.
Yeah, that is made from carbon nanotubes, and I think so it's essentially a Stanford torus, but 1,000 kilometers in radius and 500 kilometers in width. And
that's
the
advantage,
it is far. And the advantage of that is if you build the retention walls 200 kilometers in height, you don't actually need a roof or anything like that, because the atmosphere is heavy enough that it will stay inside the ring as it rotates. Yes. So it's basically absolutely vast, and as you look at it, it would look really, really weird because the atmosphere would be sort of clinging to the inside of the ring. But it's massive, obviously. It's absolutely huge. And that's the same with the Mckendree Cylinder, which is another similar concept as the O'Neill cylinder, except it's much bigger. It's 4,600 kilometers long and 460 kilometers in radius. So as you get them bigger, they take on new properties, which is exciting. So they are all your space habitats, which just leaves us with one more episode, Jamie, of dealing with habitats on planets.
This is what we're going to do next.
Moon villages, Mars villages, etc., etc.
It's a beautiful thing. Sorry it's another long podcast, but we hope you're enjoying this stuff.
Oh man, that was we got quite a lot of info.
I'm glad we're not putting a 40-minute interview in.
And me. I'm glad we're not doing that because it takes a million years to edit. But the notes for this episode are quite good, Jamie, so do make your way to the Interplanetary podcast. So,
Matt, if people want to know more about our podcast and possibly know how to support us, where should they go?
They should go to www.interplanetary.org.uk.
Right, I'm off to listen to Illinois by Sufjan Stevens. What are you up to, Matt?
I think I might do exactly the same.
Let's do it. Should we press play at the same time?
Absolutely. And then if we play it loud enough, someone in, say, Bristol will be able to hear it in stereo.
Well, I'm in Bristol tomorrow because I'm going to a rock festival called Arctangent. If you're going, come say hi.
They'll have to they'll have to step back in time, though, won't they, by a day? Be very annoying.
I'll be there Thursday and Friday, leaving Saturday morning. So come and say hi.
Yeah, so someone listens to this early Friday morning, they might be able to find you on the Friday.
No, they'll definitely find me. I'll be hanging out by the Boss area and be going to see a couple of amazing bands, Daughters, and really excited about Racket Cannon, which is rocket cannon. Are they Dutch or are they Belgium? I don't know, but they're amazing. So come and dance with me.
Dance, dance, make romance. Bye-bye, Spodcats.
See you. Goodbye.